First off, try evaluating these square roots, or click here to review. Right, the square root of 16 is 4 and the square root of 25 is 5. But what about the square root of a number between 16 and 25, like the square root of 20? 20 is not a square number, but what would you guess is the square root? That was a pretty good guess. The square root of 20 has to be somewhere between 4 and 5. Let's guess 4.4. 4.4 times 4.4 equals 19.36, so that guess was a little too small. If we guess 4.5, then 4.5 squared is 20.25, which is a little too large. So the answer is somewhere between 4.4 and 4.5. To find the exact answer, you can open up the calculator and type in the square root symbol over here and then enter 20. And here's the answer, 4.472135955 and so on. The exact square root actually goes on forever for an infinite number of decimal places. It never ends. The calculator only shows the first 9 or 10 decimal places. We can check to make sure this is right by looking at an approximate answer, like 4.472. If we square that, we get an answer that's very close to 20. So 4.472 must be very close to the square root of 20. So great, it looks like this is the right answer. So for your next challenge, try finding the square root of 34 to at least 3 decimal places. Excellent work! The square root of 34 is 5.83095 and so on. So it's approximately 5.83. And if we square that, then sure enough we get a result that's really close to 34. So let's wrap up this lesson with just a little more practice. Try evaluating these 3 square roots to at least 3 decimal places. Here we'll see what happens when we try to take the square root of negative numbers, like negative 16. But first, try evaluating these 3 square roots, or click here to review. Right, here are the square roots. And you know these are correct because 2 squared equals 4, 5 squared equals 25, and 0 squared equals 0. So let's get back to negative numbers. Try evaluating these squares and notice that we've included a few negatives here. Nicely done. Here are the answers you found. And notice that all these squares are positive. Squaring a positive number, like 3, gives you a positive result. And squaring a negative number, like negative 8 or negative 5, also gives you a positive result. What's the smallest square you can possibly have? Well, if you square 0, you get 0. So in general, whenever you square a number, you'll always get a positive result, or 0. So then what's the square root of negative 16? In other words, what number, when you square it, gives you negative 16? Do you think it's 4, 0, negative 4, or is there no square root? Exactly, so negative 16 has no square root. In general, negative numbers do not have square roots. So when you see expressions like the square root of negative 16 or the square root of negative 49, you can't evaluate them. Later on, you'll learn about a completely new group of numbers called imaginary numbers, which can actually be square roots of negatives. But for now, we won't worry about imaginary numbers, and we're saying that negatives don't have square roots. Here we'll explore roots of cubes and higher exponents. But to get started, go ahead and evaluate the square root of 25. Right, the square root of 25 is 5, because 5 squared equals 25. And what's 5 cubed? That is, what's 5 raised to the 3rd power? Great, so 5 cubed equals 125. Now we'll be taking a root of 125 and we'll put a little 3 over here just above the root symbol. So this is asking what number do you have to cube or raise to the 3rd power to get 125? And the answer is 5. So you can read this equation as the cube root of 125 equals 5. Try another example. What's the cube root of 64? In other words, what number can you raise to the third power to get 64? Nicely done. So the cube root of 64 is 4, because 4 cubed is 64. Try a few more examples. What are the cube roots of 27, 0, and 1? Right, these roots are 3, 0, and 1. So far we've looked at square roots and cube roots, and next we'll look at roots from higher exponents. For example, what's the fourth root of 81? In other words, which number raised to the fourth power gives you 81? Exactly. The fourth root of 81 is 3, because 3 to the fourth power equals 81. And you can find even higher roots of numbers. For example, the fifth root of 32 is 2, because 2 to the fifth power equals 32. The sixth root of 729 is 3, and the seventh root of 10 million is 10, because 10 to the seventh power is 10 million. Now, not every root will have an answer that's a nice whole number like these. For example, consider the cube root of 19. There's no whole number that you can cube to get 19. So try guessing an approximate answer. And by the way, this wavy equal sign here means is approximately equal to. That was a pretty good guess. The exact answer turns out to be 2.66840,165 and so on. The digits in this answer actually go on forever, and we can check this answer to make sure it's right by looking at an approximate answer like 2.668. 2.668 cubed is very close to 19, so this is the right answer. When you're taking roots, you'll often get answers that are not whole numbers and whose decimal expressions go on for infinitely many digits. In a later lesson, you'll discover a neat way to evaluate roots like this using the calculator. Let's finish this lesson by looking at roots of negative numbers. Now remember that negative numbers, like negative 16, don't have square roots. There's no number you can multiply by itself to get negative 16, so the square root of negative 16 is not a real number. But perhaps negative numbers have cube roots. Can you find the cube root of negative 8? So what number can you multiply by itself 3 times to get negative 8? Exactly, the cube root of negative 8 is negative 2, because negative 2 raised to the third power equals negative 8. So negatives might not have square roots, but they do have cube roots. Now in general, all roots of positive numbers are real. So the cube root of positive 0.471, the fourth root of 12, and the fifth root of 2034, all of these roots exist. For example, the fourth root of positive 12 is about 1.86. Raise this number to the fourth power and you'll get 12. So then what's going on with negatives? They don't have square roots, but they do have cube roots. So what about fourth roots? For example, what's the fourth root of negative 12? Well, let's think about this for a minute. If you take any positive number, like 3, and raise it to the fourth power, you'll get a positive result, because you're multiplying positive numbers together. But if you take a negative number, like negative 5, and raise it to the fourth power, then these two minus signs cancel out, and these two minus signs also cancel out. So again, we get a positive result, in this case 625. So whenever you're raising a negative number to an even power, multiplying it by itself an even number of times, you'll always get a positive result. So then what number raised to the fourth power equals negative 12? There is no such number. Pick any number, positive or negative, and raise it to the fourth power, and the result will be positive. It can't be negative 12. So we say that the fourth root of negative 12 is not a real number. In general, all even roots of negative numbers, like square roots, fourth roots, sixth roots, and eighth roots, are not real. So next, take a look at these roots here. Which of these are real? Excellent! The fourth root of positive 46 is real, and here's what it equals. Again, you'll discover how to calculate roots like this in a later lesson. And the seventh root of negative 17 is also real. If you multiply this negative number by itself 7 times, which is an odd number of times, you get negative 17. Meanwhile, these other two roots are not real. They're even roots of negative numbers. Finding roots of negative numbers is a very tricky concept, so nicely done. Let's take a closer look at the order of operations, or PEMDAS. First off, evaluate this expression, 4 times 8 minus 3 plus 2, where 8 minus 3 plus 2 is in parentheses. Great, so PEMDAS tells you the order of operations, parentheses, then multiplication and division at the same time from left to right, and then addition and subtraction together from left to right. So first you evaluated what's inside the parentheses. 8 minus 3 is 5, and 5 plus 2 is 7. And finally, 4 times 7 is 28. Next, let's see how exponents, like 4 to the third power here, fit into the order of operations. First, what does 4 to the third power equal? And click down here if you'd like to review exponents. Exactly, 4 to the third is 4 times 4 times 4, or 64. So where do exponents like this belong in the order of operations? It's between parentheses and multiplication. So the full order is PEMDAS, where the E stands for exponents. Try evaluating this expression, which has parentheses, exponents, multiplication, and subtraction. Excellent! Let's quickly see how you got that. First, you looked at what's inside the parentheses. So in here, you first evaluated the exponent and then the subtraction. 2 to the third is 8, and then 8 minus 6 equals 2. So now we're done with the parentheses, leaving us with an exponent and multiplication. The exponent comes first, and 3 squared equals 9. 9 times 2 equals 18, so that was the correct answer you found. Again, nicely done. Next, try evaluating these two expressions. Be careful, this top one has parentheses around the 5 plus 3, while the bottom one does not. Right, for this top expression, you first add the 5 and the 3 because they're in parentheses, giving you 8. Then 8 squared equals 64. In the bottom expression, there are no parentheses, so you evaluate the exponent before the addition. 3 squared equals 9, and 5 plus 9 equals 14. So having the parentheses here completely changes the expression. Now what about these two expressions? This top one means take negative 4 and then square it, while the bottom one says negative 4 squared. These are actually two different expressions. This top one is negative 4 times another negative 4, so the minus signs cancel, giving us 16. But down here, this minus sign in front is really the same thing as saying negative 1 times 4 squared. So to evaluate this, you look at the exponent before multiplying. 4 squared is 16, and then multiplying by negative 1 gives you negative 16. So sure enough, these two expressions give you different results. So whenever you see a minus sign and an exponent, evaluate the exponent first, unless the minus sign is inside the parentheses like this. Time for a little more practice. Try evaluating these four expressions, and again, be careful. These two on the top have parentheses, meaning you're raising a negative number to a power, while these two don't have parentheses, meaning you're raising to a power and then making them negative. Great work, that was tricky. Cubing negative 2 gives you negative 8. And down here we have 2 cubed, which is 8, and then you're making it negative. So both of these expressions equal negative 8. Now over here, negative 2 to the fourth power equals positive 16. But down here, 2 to the fourth is 16, and then we're making it negative. So these two expressions are not equal, and the parentheses really matter. Finally, let's look at square roots. Say we wanted to evaluate this expression. Before you evaluate a root, you first need to evaluate everything inside of it. So in this case, we're taking the square root of 3 squared minus 5. so we should evaluate 3 squared minus 5 before taking the root. Then, after we take the square root, we'll add 4 at the end, because this plus 4 is outside the square root. Okay, let's get started. We're starting inside the square root, and we'll evaluate the exponent before the subtraction. 3 squared is 9. Now we have 9 minus 5 inside the root, and 9 minus 5 is 4. So that's everything inside the root. It turns out we're taking the square root of 4, which equals 2. And finally, 2 plus 4 is 6. So this whole expression equals 6. As your final challenge, use order of operations to evaluate this expression, which also has a square root.